Hello and welcome to this video on chemical formulae and equations. Now please don't get put off by the title. It's not quite as horrible as it sounds, and hopefully by the end of it you'll be able to understand how to write chemical formulae, how to balance equations. So before we start though, we need to look at something called relative atomic mass and also mass number. Now if you choose any element in the periodic table, you will find the symbol, for example here we've got Na for sodium, and two numbers, 23 and 11. Now 23 refers to relative atomic mass, and this is the total number of protons and neutrons. And at the bottom here we've got 11, this is the atomic number. Now this is the number of protons in the atom, also tells you how many electrons there are, because the number of protons and electrons in the uncharged atom always balance. We can also work out the number of neutrons by subtracting 11 from 23, which gives us 12. Notice here, relative atomic mass is always bigger than the atomic number. Okay. Now, a bit of practice here for you. I want to pause the video at this point. I want to look at these elements here in the periodic table, oxygen down to tin, and I'd like to find out, please, the atomic mass for those elements. So find out, please, from the periodic table, atomic mass. Okay, so pause the video and I'll give you the answers in a second. Okay, so here's the answers. Did you get them right? Oxygen 16, iron 56, iodine 127, nitrogen 14, calcium 40, carbon 12, lead 207, helium 4, copper 63.5. That's a bit odd. Well, we'll be explaining about that in a subsequent video. And tin 119. So, if we know the atomic masses, we can now start thinking about the relative formula mass. When atoms join together to form a compound, e.g. magnesium oxide, we can calculate relative formula mass. So here's magnesium oxide, MgO, and we know from our periodic table, magnesium is 24, oxygen is 16, give a total of 40. Not too challenging, is it really? Well, when calculating relative formula mass, it's so important to understand the chemical formulae. We need to understand how many atoms of each we've got before we start calculating the formula mass. For example, MgO, we know there's one magnesium, there's one oxygen. In sulfuric acid, H2SO4, the little subscript number there refers to the letter directly in front. So we've got two hydrogens. If there's no subscript number there, we assume it's 1. Got one sulfur, and then we've got 4 oxygens. So this is 2 hydrogens, 1 sulfur, 4 oxygens. A little bit of a complex now. We're going to introduce brackets to it. So here we've got calcium, and in brackets we've got OH, hydroxide, and outside of brackets is subscript 2. And this subscript 2 here only refers to what's in the bracket. So it tells us there's 2 hydrogens, 2 oxygens. So in calcium hydroxide, we've got 1 calcium, 2 oxygens, 2 hydrogens. And even more complex, if you put a number in front of the compounds, here we've got 2 Na2CO3, the number in front multiplies everything behind. So we've got 4 sodiums, we've got 2 carbons, and 2 times 3 is 6 oxygens. Okay, make sure you understand that. You can see what these numbers do. Now we've got our formulae sorted. Let's look now how we can calculate the formula masses. Here we've got 1, 2, 3, 4, 5 compounds. What I'd like to do, please, is pause the video at this point and work out for me, please, what the relative formula masses of those 5 compounds actually are. Okay, ready? Pause the video. How'd you get on? Well, so look, calcium oxide, CaO, 40 plus 16 makes 56. Sulfuric acid, H2SO4, 2 plus 32 plus 64 makes 98. Sodium nitrate, NaNO3, 23 plus 14 plus 48 plus 85. Aluminium hydroxide, careful that bracket there, 27 plus 48 plus 3 makes 78. And lead carbonate, PbCO3, 207 plus 12 plus 48, 267. How'd you get on? Hopefully you got 5 out of 5. Now be aware, in some books they denote relative atomic mass as a capital A with a subscript R, and they denote relative formula mass by capital M with a subscript R. Just be aware of those in case you come across them. Now let's look now at writing chemical equations. Now, as the jar of Marmite here, you either love them or you hate them. In any chemical equation, on the left-hand side, you've always got the reactants. On the right-hand side, we've got what we call the products. Let's look at an example. Here we've got sodium plus water. They react together to form sodium hydroxide plus hydrogen. Now let's put in some formulae. Sodium is Na. Water, H2O. Sodium hydroxide, NaOH. You're never quite sure, always look up what the formula is. So here, sodium hydroxide, NaOH, plus hydrogen is H2. Now notice, hydrogen is H2. It's a gas. Now all gases, apart from the inert gases, always run in pairs, what's called diatomic. So there's two hydrogens, H2, could be two oxygens, O2, two nitrogens, N2. Okay? So when they are gases alone like this, they're found in pairs, and it's said to be diatomic. Now, we balanced it here. Why do you have to balance it? Well, this one here, we had two hydrogens there, we had three hydrogens there. So, best thing to do is put some numbers in front and see what works. So if I put a 2 there, and I got 4 hydrogens, okay, got 2, 4, that balances. Put a 2 there, 2 sodiums, that balances. And I got 2 oxygens, that balances. So, perfectly balanced equation. That wasn't challenging, was it? Let's put the state symbols in now. So sodium is a solid, water is a liquid. In fact, water is the only liquid. Okay, then we've got sodium hydroxide, which is an aqueous solution, where you've got solid dissolved in a liquid. And finally, got H2, which is a gas. As I said, because it's a gas, it's diatomic, it's always H2. You never see it alone as H. Now, you do need to know your state symbols. S is solid, L, as described, is liquid. The only liquid you need to know about is water. AQ is aqueous solution. This is where solid is dissolved in a liquid. And G is a gas. Normally we're told, if you've got a question, you're told that solid so-and-so reacted with water to form an aqueous solution of. You'll be told quite a bit about the different states. Now, there are 4 steps to writing an equation. First of all, write a word equation for the reaction. Secondly, put in the formulae for the elements or compounds. Thirdly, the most challenging part, balance the equation. Put numbers in front of the reactants and products wherever necessary. Lastly, 4, perhaps the easiest bit, complete the balance symbol equation using state symbols. Right, I think you're ready to look at some examples. First one is magnesium again. Magnesium plus oxygen gives magnesium oxide. There is our word equation. Now let's put them symbols in, shall we? Or formulae. So Mg is magnesium. Now O2, I just said, oxygen is a gas, it's diatomic, so it's O2, always O2. And that gives us MgO. You can see here it's not balanced. We've got 2 oxygens there, only 1 there. So I suggest we probably multiply that by 2, in which case we'll have 2 MgO, and we need to put a 2 in front there. Let's see if I'm right. Yes, look at that. 2 Mg plus O2 gives 2 MgO. Let's put in the states now. We've got Mg is a solid, O2 is said as a gas, MgO is a solid. There we have a complete, wonderfully balanced chemical equations complete with their state symbols. Well done. Another example, why not? This one's a bit more complex. You may not have come across ammonia before. We've got nitrogen plus hydrogen. Those are gases, so they're going to be diatomic, plus ammonia. So we've got N2, 2 atoms of that. We've got 2 atoms of hydrogen, and we've got NH3. Ooh, that's going to be challenging. We've got 3 hydrogens there. We've got 2 there, and we've got 2 nitrogens there. Let's look at how we balance it. Okay, what we'll do, we'll put a 3 in front of the hydrogen. So 3 times 2 is 6. And then in order to have 6 over here, we put 2 in front there. So it's 2 times 3 is 6. 2 times N is 2. And look over here, we've got N2 there. So that's now balanced beautifully. A bit more complex there, wasn't it? And let's look now at the state symbols. So nitrogen N2 is a gas. Hydrogen H2 is a gas. And ammonia is a gas as well. Okay, hope that makes sense to you. The best thing you can do now is to go and find some examples and have a go and keep plugging away till you really have cracked how to write balanced equations. Okay, so thanks for watching and listening, and I'll be back with another video very soon. So bye bye for now.